6 divided by 57 and it came out to be 95 and then you just had the 0.
Yeah, you could do the, you'd have to move your decimal point. You'd have to be very careful how you do that because sometimes that won't work out. So anyway, I said that there's some times where it doesn't work out, that if you don't identify what every number represents, you're going to have problems. And it'll be just like this one. Very similar looking problem. After a, let's say 10% discount, you save $35. How much do you pay? So here we have the 10%, so it's going to be 10 over 100. The 10 represents, once again, the discount. The 100 would still represent the full price. So when we go to set this up, do we have a number that represents the discount? Yes, 35. Again, we have to be missing something because otherwise there's nothing for us to find. Is what we're looking for the full price? No, we're looking for how much you pay after the discount. So this number here, even if we found it, would not be the answer to our question. Does that mean we shouldn't find it? Oh, not necessarily. Let's find it and see what happens from there. We cross multiply and divide. 100 times 35 divided by 10 is $350. But as we said, that's not the number we want. But can we use that to find the number we want? There you go. Yeah, $350 is the full price. We're going to subtract the discount from that. So we're going to subtract the $35 to get $315. So this is why I am always very careful to label these before I start calculating to make sure, is the part that's missing really what I'm looking for, or am I going to have to do something else to find it? Any questions on these first two opener problems? How about any questions off the homework from last week? Okay. Now, I had mentioned to you last week that we had 2 more lessons before we took a unit test, and I'd tentatively scheduled the unit test for Thursday, but of course with me being gone tomorrow, that'll push us back a day. So that means our Unit 2 test is going to be next week, Tuesday. So you get a whole new weekend to study for it. We mentioned when we were starting to do the percents, we mentioned something about a rate method of percent. Stick with me, guys. You know, what we've been doing, this here, is a proportion. And I said I liked it because it's always cross multiply and divide. You don't have to worry about trying to decide, do I multiply, do I divide, you know, whatever. The rate method was a little bit quicker. Now, we just looked at it briefly, but as we said, you got to try to decide, once you turn the percent into a rate, do we multiply, do we divide, what do we do with it? So we pushed it aside. But there are some applications where the rate method is just plain simpler and easier to use, when the calculation is going to be the same over and over again. One example, now most of you are going into fields where you're not necessarily going to see this, but you may branch off someday. One example where the rate method of calculation is quick and commonly used is in the commissions. For example, let's say you get into the sales, and for both dairy herd and automotive, it's possible you could get into the part sales or into the dairy supply sales. You might work off of a commission. And you might, let's say you get a 12% commission off of your sales. So if you have a week where your sales are $4,200, to figure out what your commission is, you would have to find 12% of 4,200. Now using the proportion, it's not bad. 12 over 100 equals blank over 4,200. And you would cross multiply and divide. 12 times 4,200 would give you 50,400. Then divided by the 100, give you $504 commission. Again, that's not a bad calculation, but if you're going to have to do that every week, it'd be nice to shorten it up. And I'm going to show you something with a spreadsheet here soon. It'd be nice to be able to do it just a single quick calculation on the spreadsheet. So to do that, we'd use the rate method. And since we're just finding a piece, we're finding the percentage itself, all we have to do is take our starting amount, in this case the sales, and multiply by the rate that represents our percent. So 4,200 times 12% would be what as a rate? As a decimal? 0.12. Very good. You multiply that out, and you're going to get the $504. So like I said, the proportion is still easy and simple here, but if you're going to have to do this calculation over and over again, it saves a little bit of time to do it as a rate. Now another application where this rate method is commonly used is in calculating interest. And we're going to start out talking about simple interest. It's called simple interest because it's just that. It's the simplest way of calculating interest. Simple interest means there's nothing done to the balance unless there's an action taken. Generally, that's the end of the term. In simple interest, we're going to talk about the amount of interest, which we're going to represent with the letter I. So that's going to be the amount of interest in dollars. P stands for principal. Principal is the amount of money you start with. R stands for rate. That is our percent as a decimal. And T stands for time. And our time is always going to be given in years. So let's say that you put some money in the bank and you're going to put away $4,000 and you're going to receive 6% interest for 3 years. How much would you have at the end of that 3 years? Well, our formula for the amount of interest is interest equals principal times rate times time. Do we know the principal in this problem? Yes. 4,000. Do we know the rate? 6%, but we have to write it as a decimal, so it would be 0.06. Time? 3 years, and we want our time in years, so we can just leave that as a 3. So if we multiply that out, 4,000 times 0.06 times 3, that gives us, what is that, $720? Is that right? Somebody double check me. Yep, okay, good. Is that what we're looking for? No, I asked for how much are we going to have at the end of the 3 years. That's the amount of interest. How do we find what we're going to have at the end of the 3 years? Well, our original dollar amount plus the interest. $4,720. Now, typically, simple interest would not be used on a 3-year period. A bank's not going to wait 3 years to figure in the interest on a loan or an investment either way. So simple interest typically is only used on things that are shorter term. For example, I run a business in most summers. I run a construction business. Sometimes I don't finish a job and it's time to pay my employees. If I don't have the cash on hand, I've had to several occasions go to the bank and ask for a short-term loan. I may ask for Let's say I ask for $6,000 for 3 months, just to make sure I finish off the job and I can make payroll. The bank will turn to me and say, okay, for 3 months, $6,000, we're going to charge you 12%. Now that 12% is always an annual rate, so that's considered to be 12% per year. So to figure out how much I would have to pay back at the end of the 3 months, we start out by finding the interest. You're right, 6,000 is my principal.
Times the 12%.
So how am I going to have to write the 12%?
0.12.
0.12, good. Times, now 3 months. We said the time is always in years.
So it would just stay at 3.
Well, 3 is months though, not years. So how do I make months in years? How many months are in a year?
12.
12. So that's 3 out of 12 months of the year. So 3 12s. So if I multiply that all out, what do I get? Get $180 for my interest, don't I? 6,000 times 0.12 times 3 over 12. Is that you guys come up with? All of you that are punching it in? One of those mornings? Okay. So we get $180 in interest. So then at the end, I have my 6,000 plus 180. I would have to pay back after 3 months $6,180. Not so bad? So that's simple interest. And for now, that's all we're going to use it for, is finding the amount of interest and adding it to a principal. Later on, when we start talking about solving equations and some basic algebra, we might come back to the simple interest formula and find other parts of it. But for now, that's all we're concerned about. I mentioned up here that for things that are more than just a few months, especially for 3 years, a bank wouldn't wait till the end. They wouldn't use simple interest. They would use something called compound interest. What compound interest is rather than waiting till the end of a term and figuring out interest, every set period, they figure out the interest and they add it to the account. And then the next period, you get interest on top of that interest, hence the term compounding. Anything over 6 months, generally, they're going to use some sort of a compound interest. So let's look back at that first example. We had $4,000 at 6% for 3 years. Notice I left a blank spot there because I'm going to add in one term here. Compounded quarterly. Quarterly means how many times a year?
4.
4 times a year, or every 1/4 of a year. So what they would do, I'll list out my quarters here, is every quarter of a year, every quarter, they would figure out the interest and add it onto the balance. So for the first quarter, my interest was going to be $4,000 times 0.06 is my 6%, times, it's a quarter of a year, so 1/4. So that's going to come out to be $60. So I'm going to add $60 to my 4,000. And to start my second quarter, my interest is going to be figured off of that $4,060. So 4,060 times 0.06 times 1/4 is going to be,
120.
careful, that's $60.90, I believe. Let me check. See if you guys can beat me to it. It is $60.90. Perfect. Thank you. So we get $60.90 interest there. Notice it's a little bit more because we had the interest from last time. So that means that for the third quarter, I have my $4,060 plus another $60.90 I would be starting with $4,120.90. How many times would I have to do this to get through 3 years?
4.
Well, 4 times would be 1 year. 4 quarters in a year, so for 3 it would be 4 times 3 is 12 times. Perfect. I don't feel like doing this 12 times. Let's see if we can find a shorter way. Couple of things we're going to observe here. First of all, every time we're doing this 0.06 times 1/4. 0.06 times 1/4 is 0.015. In other words, what would that be as a percent?
So it would be 15%.
Careful, move the decimal one just by 1.5%. Now this makes sense. If it's 6% per year, and I'm going every quarter, 1/4 of 6% is 1.5%. So every period, we're gaining 1.5%. Now we looked at this a little bit last week, where whenever we have an increase or a decrease, if we're looking at an increase problem, we looked at like sales tax and stuff like that. We have a starting amount, and to that we're going to add some sort of an increase. In this case, we're adding the interest to get an ending amount. And we talked about how each of those numbers, or each of those items, is represented by 2 different numbers. On one side we have the percents, and in this case on the other side we have dollars. The starting amount is 100%. In this case our increase is 1.5%, so the ending amount is 101.5% of what we started with. If we were doing the first quarter, we started with $4,000, we added the $60, which is the 1.5%, to get $4,060. What we could have done that first quarter, rather than finding that 1.5% and adding it on, we could have taken 4,000 and just 4,000, not 4,060. We could have taken $4,000 and just multiplied by, or found a 101.5%, which is a rate is 1.015. If you multiply that out, you get 4,060. Now I'm going to pause for a second. Does anybody have any questions where the 1.015 comes from? That's just the 100% starting amount plus the 1.5% per quarter. So then each quarter we'd find the ending balance by taking that number. So for the second quarter, it'd be 4,060 would be our starting balance times 1.015. Gave us the 4,120.90. How many times do we have to do that to get to the end of our 3 years? Well, still 12 times. If we're multiplying by the same number over and over again, we have a shortcut for that. It is high energy group today. If we're multiplying by the same number, what is our shortcut? We could just use a power of 12. So 4,000 times 1.015 to the power of 12 gives us an ending balance of 4782.47. With the simple interest, remember we had $47.20, so we get an extra $62.47 using the compound interest. Now in this example, that's not a real amazing number. But since we have some young people in here, let's do a couple of examples here that are a little more amazing. How many of you are under the age of 20? Perfect. So let's say you're going to get out of here, you'll be about 21, 22 years old. Let's say 22 years old just to be on the safe side. Right now for Social Security, people that are my age, they won't allow me to claim full Social Security till 67. Who knows what age it'll be when you guys get there. So let's just go off of 67 years old, which is how many years? 67 minus 22, 45. There you go. Now, right now you're in school. You're probably living a little bit cheaply, driving your old car, sharing an apartment or living at home, doing whatever you can to save on living expenses. Now, once you get done with school and you get that first good job, a lot of people want to buy a nicer car or move into a better place. But what if you didn't? What if you waited a year or two and you saved as much money as you could? Keep living cheaply like you are as a student. How much money do you think you could save and put away that first year? A couple thousand, a few thousand? Anybody want to throw out a number?
You'd have to save up at least $1,000 a week if you want to make a living.
Well, I'm not talking about what you need to live off of. I'm talking about how much would you have left over after you've paid all your living expenses if you're living cheaply. Think you could save $5,000 that year?
Probably.
Okay, let's put down $5,000. One of the reasons I put down $5,000 is federal government says you can put $5,000 a year away into an IRA, a retirement account. So there's kind of the route I'm taking this is for your retirement. So if you're going to put something away, now I'm not talking about going to the bank and opening up just a savings account because you're maybe get a 0.5% interest on that right now. I'm talking about going to an investment planner or a retirement planner and having them help you with a better investment, which way beyond my knowledge, but they can find you something to do a lot better than a 0.5%. If you put money away for 45 years, what type of a percentage do you think you could average per year? Anybody want to take a guess? No? If you look at through the last 150 years or so of the stock market, even during periods that contain the Great Depression and even the huge crash in 2009, the average gain per year over a 40-year period is right around 11 to 12%. So do you think we could safely say a 10% gain? Okay. Now, we're not going to worry about compounding quarterly or monthly or whatever. We're just going to compound once a year. So if we have a 10% gain during the year, what percent would we have at the end of the year? 100% plus 10% would be 110%. So we're going to take our $5,000 times 1.10. That's just the decimal for 110%. And how many years are we going to do that? 45 years. So the power of 45. Now before we punch this in, anybody want to guess as to what this is going to come out to be?
Probably around $10,000.
Any other guesses? About $364,000. I'm just going to round it off at that. For one $5,000 investment, that's not a bad return at 67. Think about that. If you did that 4 or 5 years in a row, you'd be looking at $1 million retirement account. Yeah. What if you decide, you know what? I worked hard to get through school. I want to play for a while. I want to buy that new car. I want to get a four-wheeler, snowmobile, whatever. I'm going to wait till I'm 32.
That's a good age.
And at 32, I'm going to start saving. So at 32, you put that same $5,000 away. And let's assume you can still get an average of 10% per year off of it. But now instead of 45 years, you only have 35 years. Anybody want to guess what this comes out to now? It's kind of depressing. About 140,000. Way less than half, almost down to a third of what you would have had if you did it at 22. So this was age 22 here. This is if you didn't do it till age 32. Now, what if you wait till you're my age? I am 42 years old. It's just plain too late. I should give up, right? Yeah. If I put away that same $5,000, and assuming I can still average 10%, which over 25 years, I may not quite be able to average that much, because if I hit a down period, I might not have time to recover. This is going to be depressing. I would only get $54,000 out of that. So me waiting till I'm 42 compared to one of you starting at 22, I get about 1/7 the amount of money that you would out of that $5,000 investment. That's the power of time. I promised you I'd show you something with a spreadsheet. Spreadsheets like this are one of the reasons why we use the rate method, because it makes the calculations a little easier. But what I'm going to do here is I just want to show you some things about how the different investment would change with your age. Again, I'm not trying to push an investment. I'm just trying to show you the numbers. And this is one of those things that I think I would be neglecting my duty if I didn't at least show you. So we're going to start at age 20, and we can adjust this as we go. We're going to put away $5,000 a year until we're 67. I'll do a little bit of formatting just because I'm uptight. And we're just doing that 10%. Again, if you did it well, you might be able to gain 11 or 12% a year, which would make a big difference. We're just going to figure 10% again. If you did $5,000 a year starting at age 20, anybody want to guess what you would have at 67?
Like, I don't know, 700 something thousand.
About 4.8 million. Now again, that's assuming 10% gain, which may or may not be totally accurate.
Well, I suppose.
Here's what's interesting about that, though. This is one of the most profound examples to me of how compound interest works. So this person, let's say that you got, let's even push this back a year, so we go 21. Many of you will be out of here by the time you're 21. So let's say at 21, you get out of here, you get that good job, and you start putting away that $5,000 a year for retirement savings. You get to, let's say, 30 years old, and you decide, I'm done. I've saved enough. I'm not going to save anything else. How much do you think you're going to have at age 67 if you just go from 21 to 29?
Not very much.
$2.5 million. Still a pretty healthy chunk. Let's go back up here.
Until you have to pay taxes and everything and all that.
Well, if you do your IRAs right, there's different taxes. And I don't know enough about taxes to get into it, but this person here decides they're going to play with their money till they're 29. Then at 30, they're going to start worrying about retirement. Anybody want to take a guess where they're at? Well, the other one was $2.5 million. You think more or less?
Less.
Significantly. $1.8 million. Now, I'd still take that, but 2.5 versus 1.8. Let's go back here and let's actually make it one more year. Let's say that this person quit at 28 instead of 29, and this one started at 29 instead of 30. How do you think they still stack up?
About 1 million or something.
Still a few $100,000 difference. This person is still ahead. They only invested for 8 years.
Wow.
This person over here started at 29 and went to 67. They invested for almost 40 years. For 39 years. Never caught up. That's the power of being young. So I throw that example out there just to show you. Does anybody have any numbers? Would you like me to put in some different ages? For those of you that are older, anybody want me to throw in some different ages? Yeah, Kyler.
Starting at age 20, so I just turned 28.
Okay.
About 3 weeks ago. If I saved up until about age 70.
Okay. That'd put you'd be actually almost exactly on this one here. About $4.8 to $5 million if you did every year.
Not too bad.
Anybody else want me to throw in some different numbers? Okay. Like I said, I'm not going to tell you what to do, but it's just an example. I would feel like I hadn't done my job if I didn't show you that one. So, actually, I'll save that later. Have a good one. So one last thing I do want to show you now. Now that we've talked about this compound interest and stuff, how do you look at getting that balance of what we would have at the end without doing a spreadsheet like that? The balance at the end, it's called a future balance or future value, is equal to the amount that you pay in each year times 1 plus our rate to the power of n, which is a number of years, minus 1 divided by the rate. So what does that mean? Here we did a payment of $5,000 times, we do have to have two sets of parentheses, 1 plus our 10% is 0.1 or 0.10. We had 45 years minus 1, then we divided by the 0.1. So if I punch that in, 5,000 times, two sets of parentheses, 1 plus 0.1 to the power of 45 minus 1 divided by 0.1. And it gave us about $3.6 million. Now the example I did on the spreadsheet was 47 years. That's why it was slightly different. I can put that in. Technically it might have even been 48 years because it started at 20 and went to 67. And there you get it. That $4.8 million was 48 years. So it's a nice little simple formula. If you want to look at making payments into savings, an annual payment and your annual rate of return. Now the other side of that would be using the same type of a formula to figure out what your payments would be on a loan. Now since you're looking at making monthly payments most likely, the formula is going to be a little bit more complex. The amount of payment you're going to make is going to equal the principal. Now there's the amount of the loan times your rate divided by 12 because it's going to be monthly times 1 plus your rate to the power of 1 plus your rate divided by 12 to the power of 12 times the number of years divided by 1 plus your rate divided by 12 to the power of 12 times the number of years minus 1. So let's say you're getting a $40,000 truck. A lot of people around here have them. So you get a $40,000 truck. They're going to give you an interest rate. Right now you can get car loans for 2 or 3%. So let's say you're going to get 3%, and they're going to spread it out over 7 years. I can remember when 5 years was the absolute maximum for an auto loan, but now they're spreading a lot of them out over 6 or 7 years. Actually, I've seen as high as 8 years on one of them. 7 years is going to be 84 months. 3% divided by 12 is going to be 1/4% or 0.25%. Or 0.0025 as a rate. That's my rate divided by 12 here. So for my formula, my payment, my monthly payment, is going to be my 40,000 times 0.0025 times 1 plus 0.0025, close my parentheses, to the power of 84, divided by 1 plus 0.0025 to the power of 84 minus 1. So let's punch that in. 40,000 times 2.0025 times parentheses 1 plus 0.0025 power of 84. Close my parentheses, divided by two sets of parentheses, 1 plus 0.0025, close, power of 84, minus 1, close and close. Anybody want to guess? Now, 3% it helps. If you bump that up to like a 9% interest, it's really nasty. But
I'm guessing it's roughly
well, $530 a month is all it is. If we were to change this to 9% interest, this would change to 0.0075 instead of 0.0025. Now remember that $530 a month, that's over 7 years. That's a lot of years. But let's change this now. To 9%. So all those are going to be changed to 7.5. Anybody want to guess? From 530 up to 645. So it's over $100 a month difference. They talk about credit ratings and credit scores and stuff like that. That's one of the places where it makes a huge difference. Okay, enough of me preaching at you for the day. In your books, on page 97, 1 through 13, the odds. Remember, I won't be here tomorrow morning for your class, so I'll see you all on Thursday. And that does push our unit test back until next week, Tuesday. You get the whole weekend to study for it, yeah. That's my way of saying